Okay, so now, good afternoon. Welcome to QHSC Concepts, Welding and NDT. Today I have brought to you, before we go to chapter 10 of SysWeb course, let's look at some defects, welding defects. I've brought a lot of welding defects for you in this chapter. Let's go through that. It will be very helpful as we go forward. You can see a lot of, brought some plate samples as well. Then I brought the radiograph as well. So let's see in this chapter something related to weld defects. So the first one is the longitudinal cracks in heat affected zone. So you will see this, usually this is heat affected zone cracks which are after 24 hours, after 48 hours, after 72 hours. This kind of cracks will be there usually because of the hydrogen pickup in the material. So longitudinal cracks in the heat affected zone, the base material is prone to hardening because of high carbon content in that material. Then the weld, if it is cooling down very rapidly, let's say you are doing a hard material welding, and then suddenly the temperature goes down because of some weather conditions, and then rain falls, a lot of rain falls, and then you are not able to maintain the temperature. Then the hydrogen in the weld is because of the wet weld edges, wrong and damp electrode, shielding gases. So those typical things which we saw in chapter 3, and those kind of elements where HIC cracking can occur, wet conditions, lack of proper geometry. You've seen those 4 or 5 conditions where hydrogen becomes issue, and then it happens and becomes a crack. So what remedies is possible to choose the material with better weldability and not apply and maintain preheat and interpass temperature and delayed cooling. So interpass temperature and preheat temperature you can maintain properly, and also cooling, if you can do wrapping and cooling it slowly, then also it will help. So apply a higher preheat input temperature also, that also will help. Removing moisture from the welding, so proper baking of electrode, usage of low hydrogen electrode, proper weld geometry, bead to width ratio and all that, it will be very important. So see another, what are the solidification cracks? Solidification cracks which you can see usually in the capping. So the formation of phases with a low melting point in the weld due to phosphor, sulfur and copper mostly in the parent material. So they maybe pick up of such material coming into the weld, and then it is going to give you crack. Unfavorable joint geometry, I said width to depth ratio. Then weld pool too large. So there is a very big joint with a very large bevel. So travel speed too low, too high, sorry. So that also can happen, result into solidification cracks. Then tack welds or root pass not sufficiently strong, or shrinkage forces in this restraint joint. So as you say, if you see you have a very fat bevel or a very large bevel, then you can have this kind of issue. Show you, for example, I have had some photographs to show. Maybe you can share some photographs of large weld pool sizes. So currently I could not find any photograph. I just try to put some photograph to show you large weld sizes. Let's see the slag inclusions. So slag inclusions are very typical slag pickup in SMAW electrodes. Usually seen a lot in SMAW, FCAW electrode also. So if you don't do inter-run cleaning, then you will get this kind of slags. Welder is too, lazy to remove the slag by grinding. After each welding pass, you will get this. Then porosity, mostly it is because of moisture, and then incorrect electrode storage, humid shielding gas. If your shielding gas is not good, then welding torch, if it is water cooled, I know very rare to have that, but if you have leak in that, probably there also it will. So moisture, rust, grease, paint, if you weld on those surfaces, there will be porosity. And then insufficient shielding gas, then of course you can remedy that by cleaning all that things, giving a very good fit up with clean, sometimes even cleaning the bevel if you want. And also porosity is because you can protect your shielding gas or welding by proper barrication by tarpaulin, and basically you have to cover the welding properly, because you may have air and it can have that problem. So undercut, arc voltage too high, arc too long, so incorrect electrode use. Electrode angle also many times problem. Incorrect electrode angle is very important when we study TKY joints. When you do the heel welding in the K bevel, it will be electrode angle is very important there. So same way in fillet joint, if the angle is not properly 45 degree, you will get the undercuts. Then deformation, if you don't have proper distortion control method, welding sequence is not proper, then you will get deformation like this. So unsuitable welding sequence, too many thin weld metal, then sometimes there is thin welded to the thick member, there also you may have this problem. So poor flat fit up, no temporary attachments used, no clamping, those kind of conditions. So lack of root penetration, root gap too small it may be, or root gap or electrode size is too big, then travel speed is too high, then incorrect use of electrode. So I will add too many things that lack of good fit up. Many times there is misalignment, because of that also root penetration is not happening properly. Let's go to welded defects in the plate type which you are given in the exam. And this is some examples I brought. So you can see here, these are the capping undercuts. So undercut is high current and voltage settings, and porosity is poor gas shielding and poor electrode baking. You can have some porosity. You can see on the parent material, because on the weld you will not see any porosity, because those are very small. You will see if any. You can see arc strike here, arc strike here as well. Capping undercut, intermittent capping undercut, you can see here. Cap undercut here also a little bit, and here bit here also. Then lack of root penetration, you can see here lack of root penetration proper. You can see burn through here, and here poor start and stop. So he came up to here, or may have started from here. He did a bit good weld, then start stop, no proper improper, and again he picks up from here, and again he is a burn through here. So it's not a good welding root joint. Here you can see clear lack of root penetration. This in the radiograph it will come a straight line. Then some mechanical damage we can see here. Arc strike is about here. All this you need to write in your specimen exam. So in this template you can see a bit of undercut, root intermittent, then ground flush. Grinding in the root is not permitted. If you are a welding inspector, you should know that it is permitted only when there is a access in the backside, and that access also in your WPS it has to say whether it is an access from both sides. Otherwise you will not be able to touch the root also, even if it is accessible. If your WPS is approved for single V without backing, then you will not be able to grind the root. So grinding of the root, touching the root, any grinding, chipping is not allowed on the root side. Okay, then arc strike, you can see the lack of penetration. You can see the entire thing because of maybe misalignment or what reason, or maybe welding reason. It is having lack of intermittent penetration. Then you can see in this some spatter and irregular weld cap profiles. Then some mechanical grinding issue, damage, and capping undercut. There is some undercut here, straight line, capping undercut here as well. So I've written down what are the factors of that. You can pause and have a look at it. Again, on this slide, you can see mechanical damage, lack of root fusion. You can see the root is very, very thin and narrow, and you can see misalignment here. So linear misalignment, lack of root fusion, both are there here. On the other side also you can see lack of root fusion because of misalignment. Then again you will see arc strikes a bit, mechanical damages. You should mention this. Cap undercut, intermittent surface, cap undercut, then mechanical damage. In an exam you can write like this as well, or how your local SISWIP guide teaches you, you can write like that, because usually we are given this sample but the weld joint is not there, so we need to write with dimension after, then put this box, put dimension, then we can write mechanical damage outside. And you can, in this you can see some slag inclusion. You have to interpret this properly, that some item is available on that bill, on the weld bead, it is surely slag. So capping, you can see improper capping here, bit of arc strike here, cap undercut all around, some porosity on the top capping, little bit of lack of fusion, capping undercut, complete filled groove. Many times you will see this towards the start or finish, there will be depression like this where it is not properly filled. In this slide you can see the arc strike, lack of root fusion. You can see very clearly the straight line, and also here you can see root undercut, and again lack of fusion, lack of root fusion. This is completely lack of root fusion, lack of, then also some spatter here and there. This one is a capping joint, and as you can see the capping is very, very thick and not done uniformly. So a lot of overlap and excess cap height, and you can see this here, slag, a lot of things. Lack of sidewall fusion here, a little bit here. Here you can see porosity, lack of sidewall fusion. You can see this is not fused also. So this part of the bevel is exposed. Some capping undercut also you can observe here. So in this is a root side. So you have excess penetration here, gas for okay, it's very small. So if it is like this very small pinhole type, you can put it as gas porosity. Excess penetration here, linear misalignment, root undercut, lack of sidewall fusion, root fusion. This also is having a lot of understrikes, arc strikes, lack of root fusion, poor start stop here, mechanical damage, arc strikes everywhere. So here you can see lack of root fusion, poor start and stop. You can see here excess root penetration. If it is more than that standard, it is given to you in the exam, and you can put it as an access root penetration. Access root penetration here. So lack of root fusion here. Some crater pipe also it can be seen here. So this one is underfill actually. You can see a lot of capping undercut intermittently. So the capping itself is not done properly. And some places you will see excess capping height, and some places you will see incomplete groove. So this is a very easy lack of root fusion, mechanical damage. Very simple to write. This one has arc strike, lack of sidewall fusion, incomplete filled groove. You can see all this line. So in poor toe blending, so you can see a lot of stress concentration area here. Then some porosity as well and arc strikes. So similar examples, guys. So if somebody wants to study this before going to exam, this will be very helpful slide for you guys. Okay, let's move to RTFI now. Let's see some radiographs. So you can see the fracture in the weld running across the weld. You can see the transverse crack. Also, I have brought one example of transverse crack. Let me share that with you. You can see this weld. It is actually a T-joint, and there is a transverse crack here. You can see very clearly in the capping. Very clearly observed. In fact, it is going towards the parent material. It started from the little bit of this capping area. So you can see it was picked up in the MPI. When we did the MPI, we picked this very clear. You cannot miss it. Okay. Okay, let's resume our journey. Okay, let's start this. So you can see this line very clearly. Sometimes you will not see this so tight. You have to do the MPI. See this line very clearly. Second is longitudinal root crack. You can see that in the radiograph it will be, if it isn't dead in the center, and you know that it is a root problem. So you can see this in the joint. It is very important to know the bevel configuration of such joints when you are doing the radiography interpretation. You can see this line. Once you see the crooked lines, you should be immediately susceptible or suspecting. You can see in this lack of penetration because of mismatch base alignment, and you can see a dead center straight line in the root side because it is in the center. So you will know immediately you have lack of fusion because lack of penetration because of misalignment issues. You will see a straight line like this, which is very dark and one side light. Next is internal root undercut. So you can see a root undercut here, not properly fused, and again it will show a dead straight line, all with little bit length in the radiograph. So you can see this. Next is incomplete penetration or lack of penetration. So here you can see both the edges of the root have not been fused, as we saw in our earlier weld defect. You can see here many places. Lack of root fusion. This, just like that. This will also be same way. If you see the radiograph of this, it will be a straight line like that, a dark straight line. Sometimes two lines, sometimes one line, depending on the radiography how it is taken. Usually it will be straight line. Then the burn through will be a big spot like this, dark and rounded in shape. Then it will come to slag lines, which we also call as wagon track. Wagon track because they are, usually in SAW welding, it will come as a track. So you can see a full, and it will be near the root side, so it will come in the middle. If it is side wall, it will go towards this side. Then comes interpass slag inclusion. Now these are the slag which has not been cleaned properly. So here and there they will come. So depending on it can come anywhere, not that only root. Fill and cap, everywhere it can come. Then lack of sidewall fusion. So you can see just after this root white region, it will be coming on the straight line on top or bottom. Then root pass aligned porosity. You can see all along the root pass there is this porosity aligned. Porosity, though very easy to understand because it is gas pocket, so you will see porosity very well in the radiograph. Similarly, scattered porosity you can see like here in this slide. You can see how this porosity is scattered all around the place. And cluster porosity, you can see like that. It will be in one spot and it will be a lot of black spots rounded in type. It will be like this. Next comes in excessive penetration, also called as icicles or drop through. So it will be white in nature and it will be a very big patch like this. Excess penetration means it has to be light because the radiography takes more time to go through that and give you a film image. So it will be light in color. If there is a burn through here, it will be dark in color. So less material, dark, and more material, it will be light in color. Then comes external concavity or insufficient filling. So you can see here on the capping is insufficiently filled, so it will be dark in color. So immediately if you see in adjacent very good joint, and here if it is dark, you must think that some material has not been deposited properly. So and cold lapse can also occur during the joint welding. So this is how to identify the cold lapse. An external undercut is also very easy. It will be a dark line on the top of the edge of the weld material, usually towards the parent material. So it is internal concavity and it will be little bit of length in nature. That's why you can see this length. It's quite a bit of length in this, or root suckback we call. So root suckback will be little bit lengthy. Next is tungsten inclusion. Very easy to understand. This will be very light spots, and also if the process is GTAW, you will be immediately knowing that it is tungsten inclusion. There is a bit of misalignment and high-low in this, and you can see within this dark patch, and then there is a light patch overall in the overall welding. So you should know that in the welding joint, and if you see the entire welding joint, all the films will not be like that. Few films will be like that, where there will be a lot of ovality. There you will see this kind of problem. Then comes longitudinal crack. So this is a very difficult thing to catch. You can see in this radiograph very difficult to catch, but when I show you this radiograph here, you can see this line. It's very clear line, and then you can, that is the reason you are able to catch this. In this radiograph, very difficult to catch. See this here, it is, you can see something here. So your radiographic quality has to be very good. So that's about it, guys. Today's lecture very important. Although some people who are not going to do CSWIP 3.2 will not require this 3.2.2. For them it is very important, but for an inspector they should always make a habit of watching the radiographs, because the radiographs teach us a lot of things, and about the repairs, and you should know all these repairs from the beginning of your inspector's career. So all the best. I hope this course, this chapter especially helped you a lot in understanding these concepts.